Welcome to the notes on area of regular polygons. So today we're going to identify the parts of a regular polygon. We're going to calculate the length of parts of a regular polygon. So what is a regular polygon? Well, just remember, it's all angles and sides are congruent, so they're all equal. All right, so that's what a regular polygon is. Now, if you notice, if you take a regular polygon, all right, which we have in the middle here, which is a hexagon, and you draw a circle around it. All right, so we've got a circle around it. You see that circle right here. Well, what do you notice? Every vertex of that regular polygon is on the circle. Okay, and because of that, we're going to learn about some parts of regular polygons. Now, the first one I want you guys to learn about is the apothem. Okay, so here's the first one. It goes from the center to a midpoint of a side. Okay, so that would be an example of an apothem. Okay, so there's a little A, and again, I put a little 90 degree because it will make a 90-degree angle. Now, I put a little note there that it also bisects the central angle. We're going to learn about what that means in a second. All right, the second thing that you got to notice is the radius. Okay, you guys know what a radius of a circle is, but now notice where the radius is. It goes from the center to one of those vertexes on the circle. So that forms our radius right there. All right, and then if you guys will notice then, what do you notice? You notice that we're going to be forming a little right triangle inside that regular polygon. That is going to be a key idea here today. Now, the last thing you need to know is a central angle. Well, to find the central angle, it's 360 divided by n, which again is the number of sides. And it's the angle formed with, it has a vertex on the center of circle. All right, and it connects, again, I get pretty definition, it connects two consecutive vertices. So right there, that's essential. This angle right here is a central angle. The vertex is on the center, and it goes to two consecutive vertices. So that's going to be a key idea in these problems. All right, let's get to some examples here. First thing they want you to do is they just simply want you to draw and label a radius and an apothem of each given shape. So it'd be pretty simple. Again, apothem just goes to the midpoint. So that'd be the A, and then the radius. Well, again, that goes from the center to one of the vertexes. So pretty straightforward. Again, here, all right, it's turned a little bit, but oops. So let me do the apothem in blue. It's turned, but again, here would be an apothem going to the midpoint. Here would be a radius right there. I think you guys can get the idea for those, and I can draw it I can draw it to any side I want. I just usually do the bottom one. Again, here comes the apothem, and then I'll do the radius to this side. It doesn't really matter. There's my radius on that side right there. Again, you can see the right triangles being formed. Okay, central angle. This is pretty straightforward, right? This is the first step in solving all these problems. Again, it's 360 divided by n. Okay, well, this is a triangle. So this has 1, 2, 3 sides. So 360 divided by 3. The central angle right there where the x is, this angle right here, that's 120 degrees. All right, this one right here, this will actually end up being a 90-degree angle. And all these angles are the same, all 4 of them. So 360 divided by 4, there's your 90. And then this one is 360 divided by 5. And that's how I'm going to get 72 degrees. So pretty straightforward, but again, super, super important. All right, let's get to two problems where we really got to put it all together. So these are the types of problems you're going to see in the homework. First one's a square with a perimeter of 20. There's all the parts we need to find. So since it's a square with a perimeter of 20, what does that mean about all the sides? Well, all the sides must be 5, right? 5, 5, and 5. This whole side is 5. Okay, well, the first thing to do is find the central angle. I like that they asked first because that is the first thing that we need to do. All right, the central angle is just 360 divided by the number of sides, which is 4. So we know this is going to be 90 degrees. Okay, that's important because our apothem is going to bisect that. So for now, it wants to know the apothem. So I'm going to draw the apothem right here. All right, again, I'm going to put a little A there for the apothem. That makes a 90-degree angle, and we said it bisects the central angle when we combine it with the radius. So here's our radius. Well, that tells me that this angle right here is 45. And how did I get that? All right, I got the central angle divided by 2 gives me the angle of that right triangle. Now, the apothem also goes to the midpoint. So that means that this piece right here, since the whole side is 5, that means that piece right there is 2.5. All right, that's 2.5, half of the side length. Now, to find the apothem, this is where all our trig comes in. This comes into SOHCAHTOA. So this right here, this 45-degree angle is our reference angle. and I'm trying to find the apothem, which is the adjacent side, and the side length over here is our opposite side. So which one involves adjacent and opposite? That'd be TOA. That'd be TOA. So to find the apothem, all right, I'm going to take the tangent. I'll do it on the side here. Tangent of 45, and that's going to equal 2.5, the opposite, over the adjacent, which is A. That's the unknown. Again, this is really over 1. We got to cross multiply. When you do that, okay, when you end up to cross multiply, you guys should know how to do that. When you do that problem, you're going to end up with the apothem at 2.5. Okay, and remember, you got to divide each side, so it's going to be tan 45 times A equals 2.5. We're going to have to divide each side by tan 45. There, you guys can see that right there. Divide this side by tan 45, and that's how you get your answer for the apothem. Now, to find the radius, okay, you've got two choices. Now that you know that the apothem is 2.5 as well, 2.5 and 2.5, you could do Pythagorean theorem. All right, if you wanted to find radius, which again would be leg squared plus leg squared. Like, again, if you want to put it at the bottom, 2.5 squared plus 2.5 squared equals the radius squared. All right, or the hypotenuse squared. But I'm going to do trig just to practice it. So again, this is my reference angle. The radius is the hypotenuse of our triangle, and we know the opposite. So to find the radius, I'll do that in red. That would just be, which one involves opposite and hypotenuse? That'd be sine of 45 equals opposite 2.5 over our radius. Again, that's over 1, cross multiply and divide. When you do that problem, you should get a radius of 3.54. So hopefully you guys can see it's all based off our properties of right triangles. Let's take a look at one more example. This time it's a pentagon. So we know that this central angle is going to be 360 divided by 5, which is 72 degrees. That's going to be important because when we make our apothem, all right, and we do our radius, we need to know that angle of our right triangle because we know that the apothem makes a right angle. So this angle right here will be 36, which again is 72 divided by 2, so that's a 36-degree angle. Now, what do they tell us? It says the apothem is 4 centimeters. So we know that that's 4. We need to find the other information. So if I want to find a side length, well, that would be this piece right here. Well, that, again, trig, that's the opposite side. I know the adjacent side. So which one involves opposite adjacent? That would be tangent. So I'll do tangent up here. I'm going to go tangent of 36 equals opposite, which is x over 4. Again, that's over 1, cross multiply. So when you do that, you're going to get x equals, that side length is going to be 2.91. So that's just this piece. This piece right here is 2.91. I need to double that to find the whole side. So my side length would be times 2. And so my side length, then I'll just do 2.91 times 2, which would equal 5.82. So there's my side length. And then to find the radius, which is right here, I would just do Pythagorean theorem. And because you know 2 of the 3 sides, so I would just do 4 squared, leg squared plus leg squared, 4 squared plus 2.91 squared equals the radius squared. If you'd like to do Pythagorean theorem, or another trig function, that works too. But when you work that out, you should get 4.94. I know you guys are pretty good at Pythagorean theorem, so I'm not going to work that out for you. But there you have finding the pieces of regular polygons, whether it's the central angle, apothem, a side length, or the radius.